All right, so for problem number 3, we have a bunch of information about a bakery and the donut counts. And it says make a scatter plot of the data based on the scatter plot, what type of function would best model the data. Now, we could enter this in a calculator, or you can just kind of do a rough sketch. So if I were to do a rough sketch, I'd probably make the cases of donuts, the x, because remember that x and y is dependent and independent. So the profit that we make probably depends on the number of cases of donuts that we sell or make. Does that make sense? So the more cases, and that's the one that's arbitrary and it counts, right? So if I sell 10 cases, 20 cases, or whatever, and so what I could do is I can just say here at 10 cases, and I can start with my 800. And you don't have to really draw it to scale. So I got this little point here, and then at 20 cases, I'm at about double that space, which is like 1790. So right here, and then at 30, you try to draw it to scale as best you can. Now at 30, it's just a little bit higher, so it's not that much higher. And then at 40, it's at 2400, which still really isn't about too much more, 2450 or whatever. So at 40, and so as I look at that, and then I could, at 90, I'm back down to 1,000. So if I go all the way to the end at 90, I'm way back down here. So it's going to kind of look like this. What kind of function is that? Well, it's definitely not a constant function. It's definitely not linear. It's probably quadratic. Now, if you wanted to do that in your calculator, you certainly could. If you just go in here to stat plot, hit edit, and then just enter in the values. In other words, I would do the cases of donuts in this one. So I'm not going to do the whole thing, but I'll just show you. I'll do a couple. So I do like 10, 20, and you could do them all. Whoops, that one's too high. 30, 40. Can somebody open this up on their Chromebook so that way they can tell me what the corresponding y values are?
I got it.
So, well, let's just do them all. So when x is equal to 10, what is my corresponding y value?
868.
868. The next one?
1790.
1790. Next one?
1990.
1990. Next one?
2450.
Next one?
2480.
Next one?
2390. 2220. 1320. 1000.
So now when I go to graph this, what I'm going to do is I'm going to, I got to go to second, y equals, and hit turn on the stats. I don't have those on, so I'm going to turn on the first one. L1 is your x list, L2 by default is your y list. And then for my zoom, I'm going to do zoom stat, which is 9. And that's what it looks like. Now, it's not perfect, but it's certainly not a constant. It's like y equals a number, right? It's not that. A linear function will kind of look like this, right? That would be like y equals mx plus b. Well, again, it's not that. Now, quadratic is parabolic. And even though it's not perfect, you can see how that could be it, right? Any questions on that one?
So the answer could never be all of the above.
No, not in this particular one. Now, sometimes you can get in really close. Like, for example, sometimes you could get something like this, and you can model a linear, and you could still come in and model a quadratic, and because of the data, the quadratic will fit it just as well as the linear. But in this case, you can't. Now, the constant in linear, you get a similar thing. You could get, it'd be hard to get all three, but I guess you could. If you were to get something like this, so the question would be, could you get all three? Well, you could. I could have a linear one that goes through. I could have a constant that goes through. And I suppose I could even have like a quadratic, if I write the equation properly, that will fit all the data points. But this isn't the case. Clearly, this one's quadratic, the way that the data is graphed. Does that make sense? Good questions, though.